Last time we were doing this smush, right? And the whole point of smush, well, the purpose of smush was you give the function some value. If it's positive, you return that value divided by 2. And if it's positive, you just return, or sorry, if it's negative, you just return the value. That's all it's supposed to do. But then we ran into an issue when I told you to do this. You had no way to do it because we had no way to make a decision in our code. Or maybe I could reword it. We had no way for the code itself to make a decision on what to do. And that's when we introduced the if. But I need to reemphasize the if doesn't operate on that bool. Oh, you can't see anything. Why did no one say anything? What's going on? Laptop? Is there a light on there at least? It's blinking. It's doing something. Now there's a red light. It's a good sign. Now there's a green blinking light. That's a good sign. There we go, finally. I'd like to all let you know everything was set correctly, it just wasn't working. This room gets worse every year. Anyways, back to what we were doing. I really want to emphasize that the if statement isn't really concerned with the statement, the Boolean expression a number greater than 0 itself. Ultimately it is, but really all it cares about is that it evaluates to a Boolean. And then based on the Boolean it evaluates to, that's how it makes its decision. It sees true, it executes the contents of the if statement. It sees false, it skips it entirely and carries on immediately after. So if we follow this code and I give it 10, a number is 10, is a number greater than 0? True, 10 is bigger than 0. So we set return value equal to return value divided by 2. And then regardless of what happens, whether or not we executed the if or not, we return the value. That's it. So based on this, write a function called isNegative that returns a Boolean, true if the number is negative, and false otherwise. Give yourself 2.5 minutes, 3 minutes to write this.
Raise your hand if you're done. Raise your hand if you'll be done in 30 more seconds. Okay, take the 30 seconds. Well, here's my implementation, and it works. Who here looks basically like this? One person, two people, three people, four people? Yeah, this works entirely fine. But I could write it another way. I could write it like this. Yeah, that works as well. Raise your hand if you did it this way. One person, two people, three, four. Now, what might throw you off with this is you see two returns in your function. But a function can only ever actually have one return that it executes. As soon as a function hits a return statement, the function immediately stops running and returns to where it was called. So let's run through this execution to make sure this makes sense. If I give it -1, a number is -1. I ask the question, a number less than 0? Well, that's true. So we go inside the if statement and we return true. Execution of this function immediately stops. The value that was returned was true. If I give it +1, is a number less than 0? No. We skip the code inside the if. We jump down to the return at the bottom, and it says returns false. With an if statement, when all the code inside the if statement is done running, it'll continue running on the line immediately following the if statement, unless we have like a return, because that immediately stops the execution of that function. So that's why this one will work. But I will say, this code here, programmers would make fun of it. And here's why. Let's consider the case of a number is -1. I ask, a number, is it greater than -1, or is it less than -1? Well, it's true, right? Because a number is -1. And I ask, is a -1 less than 0? It's true. So if true, return true. If we gave it a 1, so a number was 1, a number less than 0 is false. So when it's false, it returns false. When that Boolean expression is true, the function returns true. When the Boolean expression is false, it returns false. So I could write this code a lot simpler, like this. There we go. Did anyone do it this way?
No? I would argue this is probably what you'd see a programmer do. Someone with experience. And if you're unhappy with this, what does the code say? Let's give it -1. So a number is -1. Is a number less than 0? Help me out. True. So what does this function return? True. I give it 1. Is a number less than 0? Say false. Wake up. False. So what does this function return? Yeah. So there was actually no need for an if here, which is interesting. Similarly, these asserts, people might look at these asserts and kind of make fun of them. Now, I would argue that this is good the way they're written. But it's always kind of silly to check if a Boolean equals another Boolean. And here's why. When is negative is true, what is true equals true? True equals true. True, right? When I ask, is negative, and I give it a 1, it's going to return false. And so when I ask, does false equals false? It's true. So it's kind of funny. A lot of people might say, well, really, you don't, because it returns a Boolean, you just need to check if you get what you get, right? And then this, I would say, like, not. And this is entirely valid because the function returns a Boolean, and we could just check if the Boolean straight from the function is the one that we're looking for. However, I would make the argument that this is a little clearer because it's a little bit more explicit about, for the sake of the tests. I really want this to result in true, so I want to check if true equals true, just as an aside. Compound conditions. Because the if only cares about what the Boolean expression returns, what the Boolean expression evaluates to or false, I really don't care. I mean, Python really doesn't care how complex that Boolean expression is. All that matters, I don't care how many ands and ors or greater than, less than, equals that you have in your if statement. All that Python cares about is, well, what does that expression finally evaluate to, true or false? So you can have as many as you want in there. Now, that said, you probably don't want your Boolean expressions to be like your if statements to be overly complex, because then it becomes difficult to understand what it's doing. So you just have to be careful. There's no hard and fast rule of how long it's allowed to be. No, it's just be aware. Is this Boolean expression really complicated? If it is, maybe try to break it down and simplify it a little bit. Now, here's one. Here's a function that will, and maybe this should have returned a Boolean instead. I don't know. Doesn't really matter. But here's a function that will tell me when a number is divisible by both 3 and 5. But you'll notice on line 10, we're making use of an operator there we haven't really seen, this % sign. Raise your hand if you know what that means. 2, 3, 4, a couple people. Okay, that's pretty good. Really, we call it mod, modulo. It's a % sign, but really what it is do the division, but tell me the remainder. So if you go back to grade 2 when you learned division, remember you didn't deal with decimals, right? You didn't do that. You would always do like, 5 divided by 2 is 2, remainder 1. So if I asked 5 mod 2, the result is, what's the remainder? 1. So let's do a quick test. What's 10 divided by 2? What's the remainder? 0. Okay, cool. So I could conclude 10 is evenly divisible by 2, right? There's no remainder. What's 10 divisible by 3? 3, remainder 1. So if I ask 10 mod 3, the answer is 1. And I can conclude, well, 10 is not evenly divisible by 3 because there was a remainder. But if the remainder is 0, I know it's evenly divisible, so that's good. What's 10 divided by 10? What's the remainder? Yeah. What's 10 divided by 11? Come on, go back to grade 2. 0 remainder 1. Yeah, how many times can you break 10 down into 11? I can't. But I've got... What's the remainder? 10 divided by 11. 10, yeah. So here, when I ask a number mod 3, if the result of that is 0, I know the number is evenly divisible by 3. When I ask a number mod 5, and if the result is 0, then I know that the number is evenly divisible by 5. So let's see what happens if I give it 15. What's 15 divided by 3? Remainder 0. So the number is evenly divisible by 3. And what's 15 divided by 5? Remainder 0. Oh, so it's evenly divisible by 5. So when both conditions are true, this function returns it is, because it is divisible by both 3 and 5. Otherwise, it's false. That's all. So this is just explaining mod. Yeah, cool. Now, here's the thing with an if statement. Let me show you something real quick here. If I go and I say a equals 5, I don't know, some arbitrary value, print, this is before the if. If a equals 5, print, this is if. When I hit run, we see the 3 things printed out. What's happening? Well, first line of code, a equals 5. We print out this is before the if. Okay, that's what we see, the first thing printed out. Then I check, okay, is a equal to 5? Well, it's true because line 1 said it was. So we go inside the if statement, and then we print this is inside the if, and then we carry on. As soon as all the code inside the if is done executing, it just carries on executing immediately after the if, just like this, right? If I go here and I say, okay, 6, well, we never run the code inside the if. So an if is a great way to kind of have like this like tangential code execute and then return to carry on. But often, we want mutually exclusive execution of code. Not something like this. We want it to be, okay, if a is 5, do this, otherwise do that. But with the way this is written, it's not, we don't have a way to do that, right? This only has one branch and then returns to execution. So the way to do this would simply be if not a equals 5, let's say a was 5, a was not 5. A was not 5, now 5, a was 5. So now we have this mutually exclusive execution. Only one of those 2 if statements will execute, right? When it's 5, do this. Every other case, do that, and then carry on. But notice that whether a was 5 or 6, this is after the if is printed out. It doesn't matter. It's 5, 6. Execution still goes here. And just think about the code for a second. A is 5. Is a equal to 5? No, we skip this. We go here. We carry on. Is a not 5? Oh, yeah, that's true. Print that. Return execution to line 8. Print that. Any questions about this so far? It's important to realize this is now, instead of like, okay, the normal execution is if I go like this. If I just carry on executing lines of code. With a single if, I can take like a little detour, do something, and then come back and return the, continue execution. Where with this type of thing, where I've got this mutually exclusive execution, I get to a point, and I have to make a decision. Am I going to run this or this? Which detour? This detour or that detour? I have to take one of them. And then no matter which one I take, when I'm done, I continue the execution after the if statements. This is so common that we have special syntax for this, else. It's kind of silly to write if a equals 5 and then if not a equals 5. So the inverse case can always be caught with this else keyword. It's syntactic sugar, which is just a fancy way of saying it's nice syntax. It's like an improved version of syntax to mean the same thing. It's just the syntax is a little nicer. You said it. This is nice because first and foremost, I get to write less. I like writing less. It's intuitive and pretty easy to understand, right? In fact, I'd argue it's kind of easier to understand than even explicitly writing it out. And the other one is, whenever I start writing out Boolean expressions, I mean, that's prone to errors. Writing an else, that's a hell of a lot less prone to errors. So that's another benefit. So here's an activity. Write a function called hail that takes an integer as an argument. If the integer is even, how do we know if an integer is even? That's if it's positive. It's 9:30. You've got to pass. Yeah. If it's divisible, if it's evenly divisible by 2. Yeah. Okay. All right. Cool. And we recently learned how to check if something's evenly divisible by something, which is nice. So if the integer is even, return the value of that integer divided by 2. If it's odd, return the value multiplied by 3 with 1 added. In other words, given a number n, return n divided by 2 when it's even and 3n plus 1 when it's odd. Don't forget the percent sign exists, checking if it's divisible by 2. Take a few minutes to do this, and then we'll talk about it. Raise your hand if you're done. Raise your hand if you'll be done in like 30 seconds. Cool. Keep at it. I'm not trying to rush. I'm just checking. Sorry, what?
What's going to be the format of our test that's like next week?
Maybe we could talk about that at the beginning of next class or something. Now's not a really good time to have that chat. Okay, so here is my version. Whose looks just like this? There we go. Cool. And I wrote some assert tests. When you said test, I was confused because I was like, multiple choice? Those are just, I thought you were talking about those tests, and I was like, I don't understand what that even means. Here we go. Cool. I wrote it like that. Now, mind you, I could have written this a lot of different ways. I could have done something like this. Or maybe, I don't even need that there. I could say, that'll work. Some people like to write their functions where there really is only one return. There are some programmers that argue that's better. It's better to not have multiple returns in your function because then it's a little clearer on where the code could actually exit. Cool. There's nothing really wrong with having multiple returns either, but that's also workable. If you like this style better, by all means, go for it. Or you could go back to like what we were doing before. You could say, okay, maybe just return a number divided by 2, and we don't even need the else, right? I could do it without the else, kind of like how I did the smush, right? In fact, I could go back to the smush function, and I could change this, else equals a number, return, right? That'll work. I could have done that with an else as well. Really, I mean, there's a lot of different ways I could write this function. And all of them are correct. And I know new programmers are always thinking like, well, on the assignment, if we're doing some function, isn't all our code going to be the same anyway? I mean, look how simple this is, and look how many different ways we could actually write this code. And they're all correct. There's nothing wrong with any of them. So it really doesn't take very long. It really doesn't take the problems and our solutions to get, like, I would argue this isn't that complex of a problem. But even with such little complexity, the variations on how we can write this become, pretty abundant pretty quickly. I mean, there's literally infinite number of ways to write a solution, but maybe a lot of them are garbage. But there's a lot of reasonable ways that someone could write this solution, write this function. Okay. And then, yeah, smush with the else. Yeah. And here's another one. I mean, all of these are correct. There's a lot of different ways we could write these functions, and they're all fine. Any questions about that? Yeah?
I mean, it's kind of not really, but what does the else-if statement do that else and if don't?
Well, I'm glad you asked, because that's the next thing. So what's neat so with if, it gives you the ability to make to take a detour. With if and else, it gives you the ability to make a detour where you're kind of forced to either do that detour, and then you carry on, right? That's kind of the benefit of the else, is it gives you the ability to go this way or that way. You have to do one or the other. Where with if, you don't have to, you could just skip it. And then no matter what, the code just carries on execution. So here's an exercise. I want you to look at this code. It's broken, by the way. It's not going to work the way we want it to work. I want you to look at this code and first, try to figure out what it's supposed to be doing. That shouldn't take you very long. And then second, I want you to figure out what's wrong with it. And remember, there's only one trick to figuring out what's going on is run some cases in your head and see what happens. Just what does the code say? There's no trick question here. If you don't get the answer, it's because you assumed there was more sophistication and complexity at play. It really is as simple as what does the code say. I'm going to give you a few minutes to look at this and try to come up with a solution or come up with why it's wrong. And here, I'm going to get rid of the doc string just for the sake of having it nice and big. And by all means, talk amongst yourselves. That's fine. Does anyone know what's wrong? Raise your hand really high so I can see. Okay, not that many people. I'll give you a minute more maybe. Just look at it. If you haven't figured it out, slow down, take your time. What does the code say? Try running it in your head with a couple of cases. Okay, raise your hand high if you know the problem, really high. So here, I ran it with 55, and I get D. And that seems correct. And let's follow the code. Okay, so percent grade is 55. Is 55 greater than or equal to 90? False. Now, is greater than or equal to 80? 70? 60? 50? Ah, okay. So letter grade is D. We're done. We skip the else. And we return the letter grade, which was D, and that's what we see printed out. That's good. And then if I do 40, we get F. And let's follow the code. Is 40 greater than or equal to 90? 80? 70? 60? 50? All right, so we've got that else. It's F. Great. So let's see what happens when someone gets 99. D. They got a D. Does that seem right to you? No. But that's what the code said it should be. Let's follow the code. There's no magic. What does the code say? And remember, if returns executing, if an if statement is run, it returns executing on the line immediately following the if statement, assuming there's no return in there. So, 99. Is 99 greater than or equal to 90? Great, so letter grade becomes A+. And then I return execution to line 5, and I ask the question, is 99 greater than or equal to 80? All right, so it's now A. Is 99 greater than or equal to 70? All right, so now it's a B. Is it greater than or equal to 60? It's a C. Greater than or equal to 50? It's a D. Oh, that last one was true, so we skipped the else. And we return letter grade, which is D. We just followed the code. The issue here is these weren't mutually exclusive. The only thing that was mutually exclusive was that last else with the if greater than or equal to D. The D case and the else. Only one of those two will run. All the other ones, you just have a series of ifs, meaning you just keep checking if I do that detour of code or not. And we did that detour every single time. But what we really wanted was only one of those things to run. If any of those are going to run, I only want one to run. Right? The issue was I ran, when I gave it 99, 1, 2, 3, 4, 5 if statement conditions were true, and all of them ran. What I really wanted was for them to be mutually exclusive from one another. Only if one runs, I only want that one to run. So that's where the issue was. Yeah. And this is just explaining it. So what you have, now effectively what I want is else, and then inside of that have an if. And then if it's not that, oops, I want an else. That should be there, else, and then that one's indented 1. And then I want an else. But as you can see, this is going to start getting kind of hairy. And this will make it work. It's starting to get kind of hairy, right? I need the else's to make them mutually exclusive. But then I also have a chain of ifs I want to have. So we have more syntactic sugar. Again, that's just a fancy way of saying just nice syntax to simplify our code that has the same functionality, is we do elif, which means else if. That's what it means. And if I put these all with else ifs, except the last one, it'll work just fine. Because as soon as one of these runs, it skips all the way down to after that chain of ifs and else ifs and else. So that's what the else if is, or elif, that you were asking about. All of these, people always then ask, well, how do I know which one to use? The answer is, well, what do you want your code to do? It depends on what your code's supposed to do. Do you want just one-off things that could happen? Or do you want one of multiple things to happen? It all depends on what your code is supposed to be doing. Any questions about that? Everyone's happy with the else ifs, elifs? Yeah, cool. Now, here's an example of nested ifs. I can put an if statement inside an if statement. I can put an if statement inside 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 an if statement for all I care. Though chances are you don't really want to do that. If you end up doing that in your code, you might want to reconsider how you're coding things, because that's just getting really complex. In fact, there are some people where they have like hard rules that they will never nest more than like 3 layers deep. And if they really have to, they'll do some like extraction of their code and maybe turn it into a function just to help simplify things. But we can do that. But we also didn't need to have it with nested. We could have done this with ands. We could have said, is x greater than 0 and y greater than 0? Well, then it's the first quadrant. If x is greater than 0, y is less than 0, well, then it's the fourth, and so on, right? I could do this with ands, or I could do it nesting. If you think the nesting is a little clearer, then do the nesting. If you think the nesting is less clear than just having an and, then use the and. There's no right way to do it with this. It all depends on what you prefer. But there's nothing stopping you from nesting ifs inside of ifs inside of ifs inside of ifs inside of ifs and so on. The only thing stopping you is, well, you probably shouldn't be doing that, because if you are doing that, you're probably doing something weird with your code. You're probably making it a little complex. Maybe you should try to simplify it. Maybe you really, really need to. Maybe. Hopefully not. Yeah, and here's an example of doing it with the ands. Both are absolutely fine. If you like this, if you read it like, okay, x is greater than 0 and y is greater than 0, okay, cool. When you nest it, it's effectively an and, right? Both conditions have to be true for this one to run. It all depends on how are you breaking down the problem. There's no right answer. It's whatever you think works nicer. And sometimes you do a little bit of both, right? You don't want to nest too deep, so you start making use of ands. Or maybe you don't want your Boolean expressions to be as complex as they are, so you start making use of nested if statements. It's all situational. There's no right answer. It all depends on what you want to do. What are your goals? Okay, any questions about that? Nothing. You're all good? This is wonderful. Putting things together. Okay, you know what? By the way, I will say, I mean, nothing's been submitted and there's nothing that's been marked so far. But I will say, judging by how things are going in labs, I'm really happy with how the course is going. I'm really, so far this year, I don't want to jinx it, but so far, keep up the good work. I think you've all been doing pretty good. Never have I had, since teaching at St. FX, I've never had anyone say to me in lab, like, well, I need more caddis problems. And that happened multiple times this semester, and I was like, whoa, this is weird. But that's a good thing. That's a good thing. You want to keep practicing? That's good. Keep up the good work. Now, because I don't really want to start the next topic, now is a good time to answer your question. You wanted to know about the format of the test? It's really just going to be a bunch of short answer. And I want my short answer to be short. There might be, what I often call it is I have short answer, where the answers are really short. And then I just have short answer where maybe you have to write a couple lines, you know, a little function or something, but it won't be too big. If you're ever writing one of my tests and you find yourself writing lines and lines and lines and lines and lines of code, stop it. You're doing something wrong, trust me. So the first types of questions, the types of questions you're going to see are, here's a problem, write code to solve it, right? What would the code look like, right? I'm not going to ask you to write huge complex functions though. That's in the eye of the beholder, but I'm never going to do something I think is going to be, it's just too much. And I'll say one of the reasons for that is, my goal is to test your understanding. If I start making things complex for the sake of complex, that might trip you up, and I'm not really getting a sense of how you understand things, right? But more importantly, harder questions are harder to mark, and I want to make my marking easy, right? I don't want to mark anything that's hard to mark. So the types of questions you get are going to be things like, here's a problem, write the code for it. So like, here's some input, here's the output I want, write the code for that. I could also ask, here's the input, here's the code, what's the output? And sometimes I even like to ask, here's the code, here's the output, what would the input need to be for that output to be produced? Those are like the three major variations of what you're going to see on the test. Again, difficulty is also in the eye of the beholder, but the way I like to write my tests are, if you know what you're doing, I want you to get as high, I want you to get as close to 100 as possible. If you don't know what you're doing, you're probably going to get as close to 0 as possible. I want the test to be a good measure of how well you understand things. So if you're comfortable and you think you know what's going on and whatnot, you're probably going to do very well. If you're like, I haven't been keeping up to date with things, I really struggle I'm looking at the assignment, I don't even know where to start and whatnot, you might be in trouble and you want to get on top of that ASAP. So if you know what you're doing, you're probably going to find it easy, probably. If you're kind of lost in the course, I'd get on top of that ASAP because you're probably going to get pretty close to 0. Cool? That's not to scare you. That's not the point. That's supposed to be motivating. All right? So I want to see everyone get close to 100. But if you're here and you haven't been doing anything, you don't understand anything, I don't want you to get close to 100. That's unfair to everybody else who does understand it, right? And everyone who has taken this course before, for example. Any other questions about that test? Yes. Yeah. Now here's the funny thing. The rule is if it's in pencil, it's not eligible for a remark. If it's in pen, it could be remarked because pencil can be changed. In reality, who the hell is going to write a test like this in pen, right? That's a recipe for disaster, right? So, and this is really, this is what we're supposed to do, is I won't hand back the tests. I'll post the marks on Moodle. And if you want to see the tests, come to student hours, and I very happily show you the test, and we can have a look through it, and we can talk about it. But if the test doesn't leave, then there's no worry about if there's an issue, a remark is easy peasy. As soon as the test leaves my hands, suddenly if there's an issue, it can't be remarked, it's a nightmare. Anyways, as always, if you're stuck, thoughts, concerns, questions, want to chat, come to student hours. I get really lonely. So, yeah, come to student hours if you need them. I'll talk to you all later.